So we need to find the equation of the circle which passes through these points 0, 0, 3, 1 and 8, minus 4. So to do that, we start with it would probably help to draw out the circle and mark the 3 points 0, 0, 3, 1 and 8 minus 4. And then the way we can find the equation of the circle is if we join these points, then they would be the chords, and then we mark a center, and we know the circle theorem that the perpendicular drop from the center to a chord would bisect the chord. So we can use that theorem to find the equation of, we can easily find the equation of the chords, and then we can find the equation of the line that's perpendicular to the chord. And then if we solve these two equations simultaneously, we should be able to find the center, and then we can write the equation of the circle. So that's how I did it. So that's my perpendicular bisector. My diagram is not drawn to scale. So what I wrote down is a circle theorem. So the perpendicular from the center of a circle to a chord would bisect the chord. This is the theorem on which the solution is based. So let O be the center, and OX and OY. So this is OX and OY are the perpendicular bisectors. And then we need to find the gradient of AB, which is 1 out of 3. And the gradient of OX, which is perpendicular to AB, would be minus 3, because the product of gradients would be minus 1 if the two lines are perpendicular. And then we find the coordinate of the midpoint, which is x. So my diagram is not drawn to scale, so it doesn't look like it's a midpoint. So but x is the midpoint of AB. And then the coordinates of x would be 3 out of 2 and half. So we can write the equation of OX. So we have the gradient. So y equals minus 3x plus c. And this line, not the gradient, sorry, equation of OX. So this line OX would pass through the points x, point x, 3 out of 2 and half. So I can just write y is half and x is 3 out of 2 to get the value of c, and you get c is 5. So the equation of OX would be y equals minus 3x plus 5. So similarly, we work out the equation of OY. So so you have the gradient of BC is minus half, the gradient of OY is 2. Equation of OY is y equals 2x plus c. So we need to work out the c, and the c would be minus 10. We work out the midpoint y, that is minus 4, 2, and that would, substituting this in the equation y equals 2x plus c, we can work out the c is 10. That's a y-intercept c, okay? C is 10, and so the equation of OY would be y equals 2x minus 10. So we've got these two equations. If we solve them simultaneously, then we get to know the center. So the center is O3 minus 4. So once we have the center, we work out the equation of the circle, that would be x minus 3 whole square plus y plus 4, that's a minus sign, y plus 4 whole square is equal to the square root of, again the square, r square, so the radius would be OB. So OB, you could also do OA as a radius, but I did OB as a radius, they're all the radiuses, OC and OA. So I did OB, so I know the coordinate is 3 minus 4, so it's 3 minus the distance OB, 3 minus 0 whole square, that's 3 square, plus 4 or minus 4 or minus 0, that's minus 4 whole square. So because it's all squared, so I haven't written the root at all. So then this is the equation, the square of the radius. Okay, so because it's x minus a whole square plus b whole square is r square. So a and b is the center. So in this case, AB is 3 minus 4. So r square we've written here. So if we remove the brackets, we expand it, we get x squared plus y squared minus 6x plus 8y is 0, which is the required equation. So we have cancelled this 3 and 4. So we were left with this. Okay, so that is the answer.